Hello, Roberto.
Hi.
Hi. You're here with Unison assembly code generation using constrained programming.
Yeah.
Tell us about this. What is this?
So, okay, so just to take it from the beginning. Basically, a computer is a very, very stupid machine. The only merit is that it can do a lot of very stupid things, but very quickly, right? It's like a calculator, but it goes very quickly. And when we program a computer, typically, as humans, we want to give it orders on a high level. Like, do this and do that, in some language that we understand, a programming language. So somewhere in the middle, you need some tool that translates what we humans tell to the computer to what the computer understands. And this tool is basically what we call a compiler. A compiler generates assembly code. That is the language that the computer understands. So what we do here is that we apply mathematical optimization techniques, and in particular we apply constraint programming to get the best possible translation. So that we can run code that executes as fast as possible, or maybe save as much energy as possible, and so on. So that's what we do in a nutshell.
I see that. Do you have a demo here?
Yes, I do.
Yeah. Do you want to show us? Yeah. Okay. So talk us through this.
Yes. Okay. Let me go back to the most boring terminal. So what we show in the demo, this is basically how we compile. That is how we translate a program from a programming language. In this case, this is a C programming language, all the way down to assembly code. So this will be a factorial function. It's a typical function from mathematics, program in C, the iterative version. And if we want to get the best possible code for a certain processor for this function, one naive idea that we could try is to look for all possible solutions by just enumerating all possible combinations that we have there to get the best possible translation. But this, if we just did this, follow this naive approach, it will take us days. We could be still sitting here tomorrow and over the weekend waiting for the answer. So what we try to do here, we try to be a bit smarter than that and apply ideas from this constraint programming field that allows us to reduce the time, basically, that it takes to get the optimal solution. By doing that, we see that getting the optimal code for this factorial function, the optimal assembly code, it's reduced to this short process that it's about to finish. Now we found the optimal solution for the machine. And if we want to take a look at the code that we actually generate, here we compare the code that we generate with Unison, our tool, to the left, to the code that is generated by LLVM, that is a more traditional compiler or translator. And what you see here is that even if factorial is a very, very stupid, it's like the bread and butter of compilers. It's a very, very simple function. Using our technique, we save one cycle, that is, we can generate code that is faster, and we save one instruction, that is, we generate code that is smaller as well. So it's just a win-win.
Thank you very much.
Yeah, no problem.